Good morning. Like I said, my name is James. So the very first question that we have is, why are passwords still the best thing that we have? And so from previous work, we know that no alternative comes close to the combination of usability, deployability, and security. And that no alternative retains even the full set of benefits that legacy passwords provide. And so because of that, we know that trade-offs will always exist, and there really isn't a silver bullet. However, there's been a recent push from industry to create a new method of authentication, FIDO2. And FIDO2 uses hardware or software token that generates a unique key for each website. And FIDO2 touts improved security, strong account security, and it provides one key for all of the user's accounts. However, there are still some issues when it comes to recovery, scalability, and the mental models of users and usability. For instance, FIDO2 protocol does not include any type of recovery from loss. And similarly to passwords, a user must register a token with each website, and then they have to register a backup as well. And from recent user studies, we have seen that users have a very hard time understanding the security and functionality of FIDO2. And many users are concerned with losing the token, and that there will be longer times for authentication. So we asked ourselves if FIDO2 was really good enough. And so the primary question that we had about replacing passwords was if we could address the issues with FIDO2 by focusing on a centralized management and account recovery system. And so our initial response to this question was that perhaps certificates could solve these issues. And then that led us to the question of if we could issue certificates to users as easily as Let's Encrypt is able to issue certificates to websites. And so to get at this goal, we performed a survey of 397 participants, and we asked them to rate their like or dislike of features taken from various forms of authentication schemes, including password managers, FIDO2, and Let's Authenticate. And so taking our previous questions and the survey into account, we found ourselves with a set of design goals. And those being automated issuance and management of certificates, centralized administration, account protection, no requirement to carry tokens, simple account recovery, and device independence. We also wanted to ensure that users would be able to have privacy from colluding organizations, as well as ensure that there would not be a trusted third party. And so let's get right into how the system works. So first, a user must obtain an authenticator application. And for this purpose, and the purpose of this talk, we're going to focus on using a mobile application. The user also has to obtain a FIDO2 compatible token. And so once the user has done this, they can create an account with the certificate authority. And so once the user has created their account, the certificate authority will generate an authenticator certificate, which is then used to authorize the device to access the CA without the use of the hardware token repeatedly. So going a little deeper, once the user has created an account by choosing a username, the authenticator will generate the authenticator key pair, denoted here as K sub auth and S sub auth. The authenticator then forwards the username and the authenticator public key to a certificate authority hosted web page, which then performs the FIDO2 verification steps within the CA. The CA will authorize the authenticator public key and send the response to the user on the web page that registration has been completed. The authenticator app will then initiate the certificate signing request and provide the authenticator public key. The CA will then respond with the certificate, allowing the user to use the authenticator without having to carry their hardware token with them at all times. And so once a user has created this account and they've received their authenticator certificate, they can then proceed to begin using the application to log into websites. So after the user visits a website, the relying party will generate a session ID and send the domain, session ID, and the method to the browser. The authenticator will then capture this information and use it to create, sorry, I lost my place, and use it to create, authenticator will capture the information and use it to create the certificate signing request, which includes the account ID and the public key for the account, the signature with the certificate signing request signed by the previously mentioned secret key for the authenticator account, and then we provide the certificate for the authenticator. And then once the CA has all this information and validates this information, it'll sign the certificate and return the certificate to the authenticator. And this account certificate proves that I own an opaque account ID. So then the authenticator will either generate or look up a session key pair, and then it will generate and sign the certificate for the session. And so this session certificate authorizes my client device to log into my account for that session. The authenticator will then, out of band, send the certificate and along with the method and the signatures to the relying party. And while this is happening, the client device will be in a static loop that will be requesting authentication from the relying party. And once the relying party has received all of the certificates from the authenticator, it'll respond with an OK, and the user logs in. So after a user visits a web page, this data is stored in an encrypted vault, which is then stored with the CA. And so the encrypted vault contains the authenticator list with the corresponding authenticator public key, which is encrypted. The map, which includes the domain, account name, account ID, and the corresponding session key pairs, are also encrypted. And all of this data is encrypted using a secret key and a symmetric key. Neither of these keys are ever known to the CA and are generally stored directly on the user's device. And once it has been encrypted locally, the vault is then stored with the CA. So what were to happen if I wanted to use multiple authenticators? So now I'm able to take this encrypted vault, and it can be synchronized between any type of authenticator that is attached to my account. However, we use a recovery kit similarly to 1Password so that the authenticator will not have the symmetric key until I provide it the symmetric key to be able to decrypt the vault. And so now that we know that we can have multiple authenticators, what happens if I have one that's lost or stolen? So the FIDO2 token can then be used to authorize a new authenticator, which then goes through the same process as previously explained to register a new authenticator, and then I'm able to revoke the lost authenticator, removing access. So then what are some of the lessons that we learned? So the first lesson was that trade-offs will always exist. We found, based on the evaluations from the Bonneau framework, that our system meets most of the usability properties as passwords, but has stronger security properties. And it also has similar properties to hardware tokens, but improves the usability aspects. And so one of the core features of Let's Authenticate is that it enables centralized management of a user's authentication keys similar to a password manager. And so our current design requires users to use their token every 10 days. And one benefit is that that's a short period of time, which means the user is less likely to misplace the token. Another added benefit is that if authenticator is stolen, the user can then use the hardware token to revoke authenticator access. However, there's a clear downside, and that is that the user must now carry the token with them on a regular basis. Users could also naturally worry that a centralized system could be breached, and that would result in an attacker gaining access to all of their accounts simultaneously. In this regard, using hardware tokens alone without a centralized management system would have an advantage, since it does not require a user to trust a cloud service provider. And so going back to our design goals and stepping through the parts of the system, let's see if we met our design goals. And so the first was automated issuance and management of certificates. And so we were able to do that by creating an authenticator application and using our certificate authority. We have strong privacy protections for users. The certificates all have a unique user ID, and they all have a unique key pair. no trusted third party, by encrypting all of the information with keys that are never known to the CA, we're able to use the CA without having to place all of our trust in it. By using the certificate authority, however, we're able to centralize the issuance of certificates and allow for recovery. By using FIDO2, we're able to provide stronger account protections than passwords. And using the application that we have built, which we call OneKey, we're able to ensure that users do not always have to carry their token with them and can instead store it in a safe place. Using the recovery kit and allowing for multiple authenticators allows a user to quickly regain access to their account in the case of loss or theft. And finally, we created a OneKey mobile application, a desktop application, and a browser extension that can all be used as authenticators. And this allows users to have their preference at what type of authenticator they would want to use. And so what are our next steps? So we are going to be performing in-lab and longitudinal studies, user studies, and we need to do further research into account recovery methods. For instance, can we use the operating systems built in key management for recovery, or should we have a separate application that manages these keys? And then we're going to perform research along with the user studies into migrating users from a traditional username and password to the Let's Authenticate service. So that way they don't have to worry about losing their account information. And so other things that are in the paper, we go into much more detail about the survey. And we provide the detailed design for Let's Authenticate. We do a systematic comparison of FIDO2, 1Password, Persona, and Let's Auth, all of which we evaluate using the framework set out by Bonneau. We also have the source code, which includes a browser extension, test websites, and Flutter applications for mobile devices, and those can be found on letsauth.org. And then we provide a security, privacy, and overhead analysis. So thank you for your time, and I'm ready to take any questions.